Now, we'll just a quick introduction to about Adam. And again, Adam is our honor speaker today, Java champion and a great friend, everything. I just don't have enough space to write down all the accolades for you. But so just a quick thing about him. He's a freelance Java consultant since JDK 1.0 and since...
And this is okay. This is enough.
Yeah,
just a Java enthusiast.
Okay, all right then. All this whole list, and please reference, I think Adam is eager to start, but I want to say that at the bottom in here is that the link to Adam's blog is here. So if you read his blog post, you can find out everything about him or ask him to and get in touch with him. So with that, I'd like to turn the stage on to you, Adam, and thank you very much again, and I'll start my sharing so you can share. So.
Okay. Perfect. Now I will try to reshare.
Yes.
This is cool. Is it working?
Not yet.
Not yet.
I have unshare mine, so you should be able to.
Ah, I have to click share once again.
Yeah, that's right. Okay, now we can see you. Okay, cool.
Cool. So I have actually to apologize for the huge introduction, but Mary's on fire. So what happened is she I said yes, and she found old homepage from your website, and copy all the stuff which I gathering to as the introduction or my bio. So usually I just saying I just like Java, but thank you for the introduction, really nice. And what you should monitor is the podcast AirHacks FM, because we recorded an episode with Mary, and we will publish it. Also, I will publish it soon in a few weeks. And I was really surprised about how deep knowledge Mary really has, and it was really nice conversation. And we didn't even cover, the streaming, just what Mary did so far with Java, and this was already fun. So what I really like, I'm not a speaker. I spend all my time developing, so actually until 1 hour before I hack code. So maybe the presentation doesn't work because there's some, Quarkus running behind the scenes, or who knows, but Java user groups are fun. So what I would really appreciate that you are asking me questions. You can ask me, you can interrupt me. This will be the best just with voice, or you can write it to chat. The problem with the chat is maybe I won't see it. So Mary, if someone asks me something in the chat, please stop me and read the message. This would be cool, actually, if this works. Okay. So what I would like to share with you is actually nothing new, but interestingly, I don't see it very often in practice, and I don't know why. And what I did, I changed a little bit the agenda, because what I wrote that I will write everything from scratch. I was like, because it's boring, because we only have 1.5 hour time. And what I found are old projects from me, 11, 12, 15 years old, which were structured in the same way. So I would also walk through the project. I can share the code with you, and they are also on GitHub, and explain you maybe a little bit what I mean by that. And you can challenge me with questions as always. So I really appreciate that. And okay. And what I also added is the CLI, because yeah, I write also lots of command line interfaces with Java. Okay. I assume we have roughly 2 hours time, right, Mary? Something like this?
Sorry, 2 hours. Actually, we normally have it 1 hour, but the thing is, I am open today, so please feel free. And then folks too, you can stay, and this is being recorded. So we can always share it afterwards.
So I would try, to keep 1 hour, but who knows what happens? It really depends on the audience. So usually, if I get lots of questions, it can be longer, but it is more fun.
Sure.
Okay, so for me, the strange thing about me is I really still like Java, and my origin idea, as I started with Java in 1995. 1995, I started with Java, and since 1997, I'm a freelancer. This is the entire story, actually, about me. And the origin plan was, to work for a company, learn as many languages as you can. So I started with C and C++. But then someone said, the true object-oriented language is Java, and I stick with Java. And yeah, this was the problem. So, and then I never did something different except JavaScript. So I know JavaScript and Java, and a little bit of Shell, of course, but and C and C++ what I remember. But this is what I do all the time, actually. And I also have fun, developing and programming. So I try to avoid management. So this is also a secret sauce. So all my peers from back then are, CTOs, CEOs, and I am the only singleton freelancer, right? So freelancing singleton, left in Germany here. So maybe interesting. So there are some online courses, but I plan to record another one. The problem is the time. So Airhacks news are just meta news about my my events. So it's nothing, it's just marketing basically. If there's a conference or something, but it's low frequency, maybe 3 times a year. More interesting, Airhacks FM. There are already over 200 episodes with various guests, also Ondro, Mary. I really like the episode with Mary, and actually we planned to record something about streaming, but the conversation was so interesting that we actually had to split it. So yeah. And there's no ads, and the podcast is just fun for me. So I actually, I met Mary in Poland the first time. There was no time, for conversations because I had to speak and my slides were not done yet. So I actually miss using my podcasts, to have a nice chat with the guests. So this is actually the entire plan. And Airhacks Live are online courses, and the next, exactly. So there is a few podcasts which might be interesting. So modulars are needed, but not easy. For instance, this is one interesting podcast. Cloud migration stories are different. They're somehow related to the talk. Okay. Now, what's also interesting? Once a month, I'm doing like a question and answer show. The interesting part is we have already 127 episodes recorded. So the show runs for 8 years already. And recently, it's even becoming more and more popular. And I'm really proud of it. A genius idea. So with the 100th episode, I said, what if I will look 100 episodes back and see what the questions were, 8 years ago, and try to answer them now from the current context or perspective. What also cool, there is a guy from Brazil called Tiago. And he tries, to catch up, and he's already the episode 62. So the poor guy had to watch 62, hours of me talking. No, this is the entire archive of Java, maybe. And and I tell you what, for instance, the last time, 8 years ago, someone asked me, is it viable to use Java EE, or Java EE will die, and we have used Play framework. And what I did during the show, I compared, the contribution Play framework with Whitefly, Payara, Glassfish, for instance, during the show. And it's turned out that actually now, after 8 years, Jakarta EE and all the relevant Java EE or Jakarta EE servers are orders of magnitude, actually, more popular than Play framework. So this is what we do. It's just fun. Okay, and there are the online workshops, and the next one is in June, but this is a completely different story. Now, of course, Chicago Java user group, and I had to prepare, what to expect from Chicago citizens. So as preparation for this show, I watched this movie. I don't know whether you know this movie. This is Plane, Trains, and Automobiles. Mary, you know it?
No, I have not seen it. Yeah, I should. Yeah.
You should. Because what I learned is
Yep.
that regardless what happens, the how to call it, Chicago citizens, Chicagoan, how to call it, Chicagoan. So all the Chicagoans would like to be Thanksgivings at home. This is the movie about. So the two guys try, to go back to Chicago for Thanksgiving, and everything goes, south. This is but great movie. So I saw actually how Chicago looks like at the end of the movie, because there was a scene about Chicago, and yeah. Okay. So Mary, homework assignment, another one, watch the movie. It's fun.
I will. This is my third one from you. Okay.
Yeah. Wait a second. After a few podcasts, you will try to avoid me. So again, no Adam again. So it's just, a whole list what to do, right? But this one is fun. The others were boring, but this is. And anyone from the group knows the movie? This is a really fun movie.
I have not.
No.
Seen, yeah, but looks like Max watched.
No one.
It. Yeah.
This is strange. I mean,
Alexander watched it too.
Oh, very good. So Alexander, you're my friend.
Yeah. Yeah.
Well, down here in Brazil, the movies are translated to another sentence, so it's very hard to figure out the name in Portuguese version. So
yeah, but you see the screenshot, right? So I mean, the two guys,
sure,
and they are
sure. Steve Martin is so funny.
Yeah, so but in Germany the title is also different. So this is a US title, and in Germany is I forgot the title, was completely different. So the titles are never actually, interestingly, never translated properly. Okay, cool. So someone from Brazil watches a movie about Chicago, and no one from Chicago knows the movie. So this is strange. So I thought, this would be a big hit, this slide, but no, no success.
Actually, Greg Chabala, he saw it too. He said he saw it long time ago, right?
Yeah, this old movie, but still fun.
Yeah, that's right.
It happens the same down here in Brazil. I'm from Brazil, but I never goes to Rio de Janeiro, so I don't know Rio de Janeiro.
Okay, so
yeah,
design. So I would like to mix now a little bit of best practices with structure. So if we start in project, we think about concepts. So so always know a good idea if I would like to try to design, a Java user group conference system or speaker management system or session management system or the meetup, something which we can imagine right now, which is simple. So I would I will try to find the substantives, the things which are important, and this become Java classes. So this would be my, my first step to think what's going on. And this is always true, because if you start with the data, you can then, start with an interface and write some tests already. So this is the basic idea. So in my opinion, you shouldn't start with a framework or the infrastructure. Start, with the concept. And basically what I find out in Java, regardless whether this is a monolith, CLI, or functions, this is always the same. I mean, we start with the Java objects, and the difference becomes how the object is mapped to the persistence. So, if this is like, Jakarta EE, Java EE, or MicroProfile, then it's probably JPA. On behind the scenes, there is an Hibernate or Eclipse link. And if this is an AWS Lambda or Azure Functions projects, usually I would use JSON-B to map the Java class to JSON. Or if it's very flexible structure, we use JSON-P. This is, the flexible mapper. And sometimes, if we just use AWS Lambda as a POJO, in the Lambda, there is already Jackson and the JSON from Google included, so we use that. But yeah, this is basically the choice. So then what I try to do, we start with the simplest possible thing you can probably do, and this is usually synchronous HTTP. So no fancy, asynchronous, reactive, or whatever. Just call it and wait for the response. Usually it works better than expected. Okay, where I'm coming from, most of my projects are boring enterprise projects. So what Mary told me yesterday, that in Chicago you have some, high performance trading companies. This is not what I'm talking about. So my projects are usually, enterprise projects with some, I don't know, boring management systems. If you are building, a load balancer, then I would implement it using reactive programming. If you are building, CRUD, create, read, update, delete application, then do the simplest possible thing you can probably do. So is the chat working? Any questions? Mary, no questions. We have 20 messages in the chat. So
those are like mostly about the movies. Yeah, so nothing about
oh, very good. So the slide was actually successful. And if someone knows similar movie, I would also interested. So until the end of the show, we say, okay, the other movie was no funny or better, I'm open, right? So I can
there are
yeah.
There are a few more like Chicago movies too, so I can compile that list to you after the.
Yeah, very important. So you see, this is what this session is about. So
that's right. Yes.
Very good.
Yeah.
So what I never liked, actually for years, I hopefully actually the Tiago listens to all or watches all my shows 8 years back, and I say, okay, if it's something inconsistent what I said, just give me a hint. And I think I always try to avoid third-party dependencies. What I always was my idea, even at Sun Microsystem times, is I said, okay, I would like to pick JDK first. If this is not enough, back then there was J2E. So I pick everything what J2E does, but I try to avoid all external dependencies, frameworks, or whatever, because this was already enough stuff to know. I'm not interested to learn and know frameworks which will disappear in the next second. So I was about, whatever, somehow not even standard, something which is implemented by by multiple products. So this was the idea. So no third-party dependencies. Right now, I tried actually to avoid all the Gang of 4 patterns and all the patterns altogether. And the reason being is because most of the patterns are shipping with the platform, right? So if you have, for instance, Quarkus with CDI, I'll show you code a little bit. So CDI and injection, dependency injection, replaces, factories, decorators, adapters. You can already skip 30 pages of the Gang of 4 book because everything is built in. And so use the platform is a big one. So what I try to do is, if I'm using Quarkus, I will still try, to use just MicroProfile and not whatever Quarkus provides, or Helidon, another project, just to tell you about competition of Micronaut. So I try, to stick with MicroProfile because it's standard. And then if this is not enough, then extend to Quarkus, Helidon, or Micronaut libraries. Why that? Yeah, because you will see soon Jakarta EE and MicroProfile outlived actually most of the frameworks, if you look at this. So, and know your enemy. This is also interesting. So this was, I'm not sure whether this is the right term, but I thought, okay, we have to, what we are fighting with or against. To give you an example, I started with JDK 1.0, and at the 1.1 time frame, roughly, so in JDK 1.0, there was no collections. There was no Java util collection. So we had several implementations of collections. So, and of course, the question is, what if, one collection provider dies and we are switched to another one? So what we tried, to achieve is collection implementation independence. This was completely solved by Java util collection framework, of course. Same story with Swing. There was AWT at the beginning, then Swing came out, and in the middle, between AWT and Swing, there were a couple of, commercial GUI providers, and then the standard was introduced. So, and then, if you remember, we had a discussion in early, 2000s, or no, 2000 was too late. It was in middle of 1995, 1997, 8. And so what we believed, or actually what my architects believed back then, is that the relational databases will disappear and we will replace by object-oriented databases, and XML databases were very fancy back then. So the idea was to encapsulate the entire persistence with DAO pattern, for instance. So the enemy was the actual database implementation, or the variance, the variation, and we wanted to protect the variations, or to decouple from the implementation by introducing an interface. Now, and what happens right now, because I would like just to touch on cloud. So if you go to the cloud, what I observe, the projects, try to do the same. They say, okay, in the cloud, we can try to decouple from the cloud, because what if we have to switch between, Azure and AWS or Google GCP? And in my opinion, the cloud is no more the enemy if you're completely running in the cloud, because it's almost like an operating system where you're running, and you have different problems. And the problem in the cloud is not necessarily that you are depending on the cloud. More like if you try to decouple from everything, the time becomes the problem. Everything becomes so complex that you actually have no time to provide business value. So so I would say, if you start to say, okay, what is the actual problem, how to solve the problem. So, and then this is, I don't know why, but still interesting. So I don't know, we developers, we like really to optimize. And what I try to do, I write the simple code, but not necessarily good code or fast code, and hope that Java will optimize for me. And I have to say, over the years, it works better and better, right? So we have string deduplication recently. For instance, you can write a stupid synchronous code and write until and wait until Loom comes out, where you can start millions of threads and hope it will scale good enough. And I would say this approach is better than start for CRUD or Hello World with reactive framework, and then use very special tools to debug the entire stuff. So it also happened already in projects. So I would say, so optimize if there is a need, and if there is no need, just write simple code. This would be the idea. So what I already wrote, Java SE features first, write simple code. Then we have Java SE libraries, for instance, base64 string logging, for instance, system logger ships with Java. I use it all the time. System.println even is usable. If you're running in the cloud, for instance, you can just write to system.println, and cloud will aggregate it for you, so you don't need fancy filters or whatever. So it's good enough. And Java 17, this is what I use all the time. And Java 19 is even getting better. And please remember, with Project Loom is on the horizon, it's already in preview in Java 19, and it will actually change for the better, right? And yeah, this was the just the introduction to programming. And so what's wrong with you? There's no questions. Everyone agreed with me so far. Okay, this is
some people were, I think, curious about your thoughts on Spring since you left it out of the framework.
Oh, I have actually I had never did a Spring Boot project or Spring. This is the truth. So I'm actually on my project doing Jakarta EE and MicroProfile. So I don't have a lot of experience with, or I have no experience with Spring or Spring Boot. The only experience I have in one project, they thought that it was Jakarta EE and this was Spring Boot, and they asked for help. So the problem was in Java SE, not in Spring. There are some memory leaks. So I helped them. So the only one would really had to do something with Spring Boot. And nowadays we are running in most of projects serverless Java, and then Quarkus or Micronaut are highly optimized, and this is what we use to save money. So and also what do you have to know? All my projects, the last 15 years were Whitefly, Glassfish, Payara, Open Liberty, lots of projects, and the Jakarta EE code I wrote last 15 years. Is very compatible with Quarkus or Helidon, and we can run the code with minor modifications in the cloud. So, and Spring Boot is not compatible with this project. This is actually the reason, because I have all the clients, recurrent clients, and they hire me over and over again. So, and we modernize, or not even modernize, we just delete stuff, and we use the same code for years. So this is why I try to avoid to talk about Spring Boot, because I have no idea. And also in the workshops you saw, there are there are always, a couple of developers who migrate away from Spring Boot to, let's say, Quarkus for serverless applications because of startup times and stuff like that. So this is why. But yeah, I don't like to talk about things which I don't do in projects. So this is the only reason. Okay, cool. Done so far. I would like just to open the chat. Where is my mouse?
Yeah.
Oh, no, I see the chat as well.
Yeah, the chat, no special questions.
Jeff Rogers. I think I know Jeff Rogers. No love for Spring Boot. I don't think, I don't love the stuff, I would say. It is a pragmatic decision, right? So for me, it should be a significant added value to use Spring Boot right now. And all my clients are happy. So the question is why to use it, right? So that's the thing. What's more interesting for me is whether we use GraalVM or not. For instance, this is an interesting question, and you will see, in a second.
Logan just asked a question too. So.
Yeah, it's more of a comment. I was just saying that Spring Boot 6 or Spring Framework 6 and Spring Boot 3 introduced first-class support for GraalVM. So I'm interested to see, what adoption it gets over time. Yep. But yeah, that was just released
interesting.
last year.
This happened in Quarkus for 3 years already. So we actually
exactly.
And this is the problem, right? So this is for years we could use this, and the interesting part, Logan, is that we actually not using GraalVM in the cloud. That's the interesting part, and I'll show you why. So we could use this Micronaut, but we are not using this for certain reasons. If you're interested, I would like to explain you why. Okay. No distributed transactions. I think this is clear. This is like an overall I don't know, best practice or reasonable practices, and reactive programming for reactive use cases. I hope the next podcast with Mary will talk about streaming actually, and then in my opinion, in streaming use cases, reactive programming makes a lot of sense, because so think about this. So stream for me is like reactive stream is more like collection or a Java util stream which is alive. So if the data arrives, I get, it pushes the data to me. So it's like event listener. I'm event listener in a thing, and this is reactive. But if I'm dealing with HTTP For me, it's not reactive. HTTP is like, it's just invoking the stuff and waiting for the response, basically. And what I really do, I'm always starting with monolith. So I actually never try, to use microservices or whatever, just create, a larger application and see how it goes. And microservice for me is just a solution to a problem. If I don't have a problem, I don't need a solution. So there are projects where without microservices, perfectly valid. Okay, so first use standards, use boring technology. Least common denominator is always good, that you say, okay, do I really need all the features, or just commit to a subset if it's not needed, and it is then easier to understand and easier to port. Make explainable choices. So this is very important. For instance, right, I have to mention a cloud a little bit, or I would like to mention cloud and on-premises first. So if you are on-premise, let's say, right, usually what happens is you can order a server, you pay for the server, but then the server is basically free. This is at least my observation in larger European companies. So no one cares about costs or what is the utilization of the CPU. You can just run it and you're done. And in such environments, what I see is developers, thinking about modularization and, decoupling and stuff like that, maybe for fun or not, or, they were at conferences. Back then, for instance, OSGI was very popular in enterprise projects, and I never saw a reason, because it was very rare that someone replaced a part of the application in running system, let's say, right? So now it's no more that common. And these choices were not explainable. If I ask, why you have, 500 modules, if you're only shipping the entire stuff, once a month with one version, and all the modules have the same version. This was even funny, right? So at first they wanted to have, multi-module projects with lots of modules. And then I saw that every module has the same version. It's okay, then why you need the modules if there is never a replacement, right? So maybe you could just, have one Maven module and nicer package structure. And if you have lots of modules, the next problem you get is that, maybe you have some duplicate classes you don't even notice because they are so distributed. And the same is true if you commit to microservices, then I would say don't think about shared jars, because the entire point of microservices is that you would like to have, completely separate teams. And if you share something, then they are not isolated teams. So I would say a project is then maintainable if whatever you are doing is very easy to explain. So it's like, I'm doing this because, and you can explain it to someone which is not, a software expert, and then it's maintainable. If you start, if the explanation is longer, it's already suspicious, right? So, and simplicity and standards, and sometimes it goes by hand, right? So what's the ultimate structure? So first, I would say the ultimate structure is in projects where the domain is emphasized. So if you are building a Chicago meetup system, then I would expect to have a package meetup at least, or, a package speaker session, sponsor, whatever. This is my expectation. If I open a CJUG, a system which manages the CJUG, and I know that CJUG is about speakers, sponsors, moderators, chats, I don't know what. So this, whatever I mentioned right now, are package names for me in an enterprise system. I think this is reasonable. And actually, if you think about this, you actually would start with classes. And when the classes become too big, you would create a package, right? So you could start what I said at the beginning. You could start, with speaker, moderator, chat, message, session, whatever, schedule. And then say, okay, but, just a speaker class, I cannot do. I need I need a REST interface. I need something more than a class, and then you get the idea. Then it's the entire package. So I have an entire package speaker, and the speaker package has a view classes which allows you to communicate with the system. So I'm already assuming here that that we are building like something with HTTP endpoint, right? So this would be the assumption. Okay, cool. Any questions? Everyone with me? So now this is a little bit boring. So what I would like to do is to show you some examples. Instead of coding, I actually found some examples, and later you will see them in the cloud. So one of the oldest example I found, and this is still on my GitHub, you see master branch, now you would have main, is the following. This was, I think Ondro will know it. This is a monitoring system for glassfish. And this is at least 15 years old. And if you see 2011, but I started with, you see, initial import. Then it was Java 1, 2011 was in San Francisco. Then the other one was older because I started usually in Mercurial. And, 2011 or 2010, I migrated to GitHub, most of my projects. But you see, this one but it's cool. I actually overlooked that. Initial import at Glassfish BOF. So it seems like the Glassfish BOF 2011 at Java 1 was really boring. So I did, I started with the project, or I got, the idea for this. I don't know why, but it's fun, actually. Great piece of history. So now, so let's take a look. So what you already see is I have a module and a system test module. So this didn't change. I was actually surprised that this is so old. What I do right with the ST. So what means is I have always two modules in microservices. One module is the main part, and the other one is the system test part. See, the most common question is why I have two, and the answer is because if you think about real world, the system tests should not share any dependencies with the real system. Only then you can really test, a black box the microservice. So in this particular case, the Lightfish ST, I think it is going to be, the test, the JAX. Exactly, it ends with IT, and forgive me, it is not 9 years old. But you can already see it looks somehow not that bad. Oh, I use a countdown ledgers or whatever I used back then, or I'm starting a WebSocket container from Jakarta EE back then and testing in WebSockets. Wow, this is not bad for the time. So and then the system test, tests the module, and the cool story is if you do this, then you have the following. You can have multiple versions of the system tests. You can check out the older versions and run them against the newest version of the microservice and see whether it's backward compatible. If you only have one module, it is really hard or even impossible to do the same. Okay, this is common, and usually this stage is compiled in a pipeline and run against this first one. So now about the structure. So we have here business. Why business in presentation? I'm not doing this anymore. Back then, Java server faces were very popular. So the first part is backend, and this is the front end. So right now, there's no more business because I don't know whether you remember with some microsystems. So back then, there was like presentation, business, and integration tiers, and client tier was Swing. And as you can see, this monitoring system comprises administration, app monitoring, authenticator, configuration, escalation. So I think they were alarms, heartbeat, logging, and REST is a little bit strange. Client publisher. This is I don't like the name strange REST. So this is, but yeah, okay. It publishes wow. With CDI 9 years ago. So it publishes the client, which is JAX REST client. And this is why I called it REST. Okay. Almost excuse. Now I wouldn't do this. This is a technical term. And server monitoring, you see, this is boundary. And the boundary back then, stateless EJB, which this is even request scoped, and there is something where singleton path produces concurrency. You see, produces application JSON, and this exposes whatever here. This creates a timer, and this is just calculation job. So what means is the top level packages are like components. They are encapsulated, and you can see they tend to have a structure. It's called a boundary. This boundary control entity, everything looks the same. So now the question is why I'm calling this boundary control entity. And the problem, I already mentioned enterprise projects. The problem is at least in Europe, the architects really love to talk about names. I'm no more now, I would say, and now we have different problems. But 5 years ago, still there was a huge discussion how we name things, and I used my own names here, like service and domain or whatever, and always have to explain why I use service and not endpoint or whatever. And then I found a book from Ivo Jacobson, and there was mentioned boundary control entity, BCE or ECB pattern, and because the book almost standard. And also these BCE icons I show you in a second are available in all possible tools, from Enterprise Architect, Magic Draw, Draw.io, more modern tools, OmniGraffle, Visio, everywhere. You find the icons everywhere, and they're also described in agile modeling. So if you go and agile modeling is always good. So this was like an interesting survival strategy. It's called agile modeling. And let's see whether we'll find the diagram, hopefully. Not yet. I would agile modeling diagram. You should never, search for diagrams in a talk. Boundary control entity. So this is boundary control entity. This is boundary control entity. These are the diagrams. So you saw them for sure. They were even available in UML. They were classed with stereotypes, but I don't care. So okay, look, they are already defined multiple times, and I also use them for front ends, for web components projects. Also the same idea. So what's the idea? Very simple. The boundary is like the perimeter to the outside world. The control is like reusable logic, and entity is the data. That's all. It's always the same. The problem with it, you are forced to come up with really good names. So the challenge is, to deal with the business logic and find good names. So this is the challenge. So this project is, as I said, 15 years old. And funny fact, some of the components I found it actually today don't have the structure. So I have to find that. Escalation maybe. Yeah, you see notification. It's strange what I did. And it was not written by me. It was by Rob. And what I remember back then, it was actually funny. The entire system was used to monitor something in Canadian government. And I got lots of the contribution. And then I didn't want it, they were under pressure to change that. But if you look at this notification, what I would do, or the transmitter and transmitters, I wouldn't, substructure this. So what I tend to do is I would do, the notification on the top level, and maybe transmitter and transmitters also on top level. So I don't like to nest the folders here. It should be simple. Yeah. But again, hopefully I'm excused because this is not already 15 years old. So, but I hope you got the point. So another project, what I would like to share with you is the X-ray, which is for my blog, actually. It's like statistic project. And why I show you these such strange projects, right? Because I'm a consultant. I cannot show you, until one exception, which I'll show in a second, the real projects because of NDA. So whatever I can show you is the projects, or my open source projects actually. But X-ray services. So another one is the same age, roughly. So I can show you this. Okay, no Git, I deleted the Git repository, but it's roughly 11 years, 15 years old as well. And please notice the structure, JavaX, WS, and path singleton. This is Java E code. Why? Because today I will show you the, a little bit more sophisticated, modern MicroProfile code. And the point is, it is identical, the structure, to this one. And even though you could actually migrate this to a Lambda. And by the way, another funny fact I forgot to mention is a little bit dangerous again, but try it. And I'm being JDD 2022, 10 years after. Yeah. What I did here in the talk, so I'm looking a little bit, scary here, but what happened is I was at a conference called JDD. Maybe Mary attended the conference once. It's a large Polish conference, actually larger with this, which we attended. And the first time I was invited was around 2012, 2011. And what I did back then, I wrote on stage an application and said Java 6 is like, the future is now. And they invited me again last year, sorry. And I remember, I know the conference from somewhere. And what I did, I found the code I wrote on stage. And what I did now is in this video, you can look afterwards, I migrated the old code to AWS Lambda in, I don't know, 10, 20, 15 minutes. And it works without modifications. So I would say this is one of the reasons why I'm not doing Spring Boot, because I have lots of such projects and I'm busy 150% of my time. So there is there's no room for Spring Boot in my world. So that's the reason. Maybe there is a love, but no time. And love without time doesn't work. So that's the problem. So what's wrong with the chat? Everyone is quiet. So are you sleeping already? Are you so excited that you cannot even ask questions? So Mary, if no one asks questions, you have to ask questions. This is your job.
Well, okay. Why don't you continue speaking right now? For JDD, I did not go there, but I heard good things about it. So
okay,
that's just a comment, but yeah.
Okay, so if you look at this, the same story, right? We have cache, configuration, grid, hits, like the block hits. We have logging, monitoring, persistence, statistics, and versioning. And if you open, the folders, you see, there's boundary control. And now, what's interesting here is just control. You see, this one is boundary. It means this is an API, which is very simple because there's no control. So this is boundary and control means this is the configuration is without persistence, because the persistence is, this is a hash map in memory hash map. So therefore, there's just no entities. And this grid control is just, the grid seems to be like utility class because there is no API to the outside world. More interesting. So we have here the boundary, and the boundary is a hits resource. A resource means, JAX resource or REST resource, so path hits, and there is a method put and method get, and imports resource is the same. And then we have control, which is the actual logic, which is unit testable. You see, there is no annotations, nothing. You can just write unit tests for it. Filter provider, whatever. So it is actually not, again, this code is 10 years old at least. And entity are actually and you see back then I used JAX-B for JSON serialization. Now I would use JSON-B. So this, I will have to migrate this. And how I would do this, I would either migrate this to Java record or, use here the public fields and use JSON-B. This would be a minor migration. Hit, the same story, and post, the same story. So this is actually the thing. So logging, so we have some logging, monitoring, boundary entity, and this is wrong. This should be, performance auditor should be in boundary or entity, not the top level. Here's the boundary entity. If there's just boundary and just entity, I'm already without knowing it. So I would say, okay, if there's just boundary and entity, this is a very simple CRUD application. There is no logic because control is missing. And persistence is like just, the access layer. Statistics seems to be complex because boundary is the access to the outside world. Control is like, calculator, a little bit of logic, and entity is the data, is like the transport data. And of course, right now, I would use, for instance, Java records for it. But what I would like to do to explain you was this simple structure, which is consistent everywhere, is always the same thing, right? So now I got the okay to show you the project I'm working on right now, and to show you this. And this project is current one. This is actually Quarkus, and I would like to switch to here and open it. And this is larger so if you go to source main Java, you see these are top level components. If you open the components, we see boundary, account data resource. If you notice, this project, is maybe, I don't know, I mean, we work on it for 1 year, but I committed today some code, right? But if you look at the packages, it is identical to my 15 years old thing. So the cool story is, in my world, we never had to migrate somewhere because, it was always compatible. This is actually the great added value of Jakarta EE, J2E, and MicroProfile. And by the way, for me, Java EE, J2E, Jakarta EE, and MicroProfile is the same. So MicroProfile is a subset of Jakarta EE with a little bit more features. Guru asked me, and Guru has a lost question. Oh, please split the question to multiple questions, but this one is excuse. I try to do this.
Okay.
Very good. So Jeff Rogers asked me, where do you make calls to other packages from the control or boundary classes? So it is a very common question. I try to draw it for you. Wait a second, maybe it will work. If not, I will just explain you this. So we have the package, and the package is speakers. So this is boundary control entity. And let's say the speakers package here is boundary control entity. So we have here session. So, and what Jeff asked, what are the rules for interactions? And so if you think about this, so here is the actor or someone who uses the system and calls the API. So if you think about this, this is kind of transaction. And I would say it doesn't have to be JTA transaction. So if you go to AWS and you invoke a Lambda, Lambda will store it in a DynamoDB, is a transaction. So DynamoDB understands transactions, at least in our call. If this is an S3 call, S3 is also transactional. Put and read. There is a read after put, and it is transactional. Why it is important for me? So the methods here are use cases. Are single use cases. Sorry. So these are use cases. And if you think about this, a use case is or something with added value to the user, a button click or whatever, is atomic. You cannot just half push the button, right? So this is why I try to prevent this. Prevent means it is allowed but discouraged. So I don't like to have nested boundaries. What's okay is to have this. This boundary can call this control. What is less okay is this, because this is like these classes are just data. It is actually not good if this boundary, which is very high level API call, knows about the internal things of these components. It would be better if this boundary will call this one and this will go there. So this is perfectly fine. This is perfectly fine. And what you already see is in my projects, cycles are allowed, because what can happen is that this one invokes this one and we have cycle between packages, but no one cares, it still works. Right? Because it is not the idea that we will ever, distribute these two components to different microservices. If we would like to do it, we'll tear it apart with some effort, but this is not like we're dreaming that everything can be distributed. Okay. Okay. So I did this in, I don't know how many projects, but a lot. I'm already assuming that this structure is built in at least 100 different projects. And the cool story is the developers really like it. And the reason is they tell me then they don't have to think about this. So there's just, if you know business logic, you can write a system. If you don't know the business logic, you cannot write a system, which is a good thing, right? So what means in my projects, there are no DAOs, DTOs, VOs, util, commons, foundation, all the names which are generic and are meaningless are not allowed. So in my code review, I will ask why Chicago Java User Group speaker management system cares about DAOs? Who cares about that? So show me what you are doing and not how you are doing this, right? So this is maybe, so this is, and the sponsor already said, you know, it's always curious if there's one way to do this. So it really depends, because if we are building infrastructure, this is the interesting part. So we are emphasizing the infrastructure parts, which looks very technical, but is different context, right? Okay, so I'm just now Guru ask. GraphQL gains quite some traction in startups too. MicroProfile is not yet there with the specs. Kind of true, because if you take a look at Smallrye, there is a GraphQL subsystem, so you can actually use it. And and I try to avoid GraphQL in smaller projects, and the reason is if you do GraphQL, the problem is you will have to write the resolvers, and GraphQL, I would say, is great. If you don't know GraphQL, it's like, how it's called, Hibernate by example, I think, right? Entity by query by example. It was query by example by Hibernate, and what it did is you could send a pre-filled entity to the backend, and Hibernate will generate the queries for you. And GraphQL is very similar. So you're sending, you know, the pre-filled answer, and the question is generated from the answer and sent back to you. But the problem is, in order to make it work, you have to write the resolvers. So usually it has to be a bigger project. But for the front-end people, GraphQL is nicer. For the backend people, not always. And there are also security implications with GraphQL. We don't have time to talk about that. But the point is, right now, I'm not using GraphQL. And Guru, you know, I don't know about startups because GraphQL is really old, right? So this is not like it's the hottest stuff. It is almost forgotten already. And yeah, and if you care about GraphQL, you can look at, if you are on AWS AppSync, actually, it's also similar to this. Okay, so then Derek asked me, I would argue that GraphQL is not just for startups, for tons of exactly is using it, but it might be skewed in work with GraphQL. Yeah, Derek, you're right. So absolutely. So in enterprise companies, I see it more because the teams are larger. So it's not a problem, you know, for a team to dedicate a few people who create the resolver queries. And what's really interesting is there are some databases which understand GraphQL natively. So this would be interesting, but I'm really not interested to build the resolvers. So now, Rene, it almost sounds German. So from Chicago. I've worked with Spring the last years. I want to work with Jakarta EE. Which introduction you can recommend? Books, websites. So I don't know whether it is worth, you know, to differentiate between Jakarta EE and MicroProfile. So I would like to say, start with MicroProfile first. I think the subset is more than enough because, okay, I would just, you know, shut down my tablet here and show you something to understand more because a clarification. MicroProfile, hopefully they didn't change the website. No. So these are the specs from MicroProfile. So there's Jakarta EE core profile, which is CDI and stuff like that. So this is actually very new. So we have health, JSON Web Token, metrics, fault tolerance, and so forth. And you see the Jakarta EE core profile is actually this, what I showed you right now. It is CDI, it is JAX-RS, and so we have, where is the list? But it is bin validation, I suspect. Bin validation not there. There's a CDI, JAX-RS, JSON-B, and JSON-P. This should be, and everything else comes from MicroProfile. So what it means is to have a serverless or not serverless, even container, cloud, native Java projects, Jakarta EE core profile is enough. And usually would like to have, you know, metrics, let's say. REST client is great. Config is this what you get injection from environment entries. So I would say if you pick MicroProfile, you get Jakarta EE plus, you know, the cloud goodness. This is my approach. And how to start with it? I would say Quarkus, Helidon, and Open Liberty. Great documentation, right? So this is just go with it. Okay. Cool. Now you woke up. Perfect. Where I can put the structure, business services, and database calls. Okay, very good one. So in my projects, database calls are just controls because if the database is relational database, we have JPA, and this JPA thing already implements DAO and all other patterns. So there is no need, to encapsulate DAO once again. So with the, I don't have it here. So, but I can show you in my projects actually here. What we have here in this project, there is a nice component called persistence boundary, and there is a control. And if you take a look, so this is the persistence with, we have delete object, get number of objects, store, and so forth. And we have several implementations. We have file persistence. We have the S3 persistence, and we have the in-memory persistence. So we have various persistence implementations, but why we have this, this package at all? Because we have 3. If this would be a stock Jakarta EE project, there would be no persistence package. I would just inject with persistence context the entity manager, and I could implement create, read, update, delete with 4 lines of code, right? So what it means is we don't need to decouple from standards. This is a cloud project. So on AWS, working with S3 is not always fun. Working with DynamoDB is not always fun. In Azure, the same. If you have the Cosmos DB, there is no nice, like a JPA implementation for it. So we tend to encapsulate this with interface or an implementation. I hope it is clear. If not, ask me. And business services, if there are different, other microservices you are calling, you can inject an interface. It's called MicroProfile REST client with one annotation, and you are done. So there is no reason to have, additional framework. So everything is actually solved there. Okay, cool. Thank you for the question. So now it becomes more and more interesting. Okay, so the boundary is like the perimeter, is like the the only contact to the outside world. So for me, the boundary is like if the component would be a Java class, the boundary would be the public methods, right? The control would be the private methods, but complex one, or package private. Package private is better. Package private. And entity would be Java records in the class, for instance. So, but you cannot write a class, right? You cannot write a microservice with one class, so you write more classes, and therefore we start with Java packages. Okay, I hope it's clear. So, really, it is no kidding. I don't see a reason to pick different structure. Why? Because this structure is about emphasizing the business logic. And the question is why I should emphasize something different, right? Because the business logic is actually this, what you are get paid for. And this is the added value of the application. So this is what the talk is about. So just, try to show what you are doing and not hide what you are doing and emphasize patterns which are pointless in our viewers anyway. Cool. So this is how it looks like. These are the icons, beautifully crafted by me with some shadow even. So boundary, control, entity. And these are the components. So another question from Florin Christian to ask. I couldn't understand you. Just Micronaut. I heard something with Micronaut. But Florin asked me, what is an acceptable startup time from your point of view with serverless and MicroProfile? Very good one. So currently the startup time on AWS are roughly 2-3 seconds is the startup time. Actually plans to show you this. And with larger application. So we have one application right now with several hundred classes, and the startup time with Quarkus is 2 to 3 seconds. The cool story is, if you pay 15 euros a month, roughly, it really depends, on everything. But if you have the provision concurrency, what happens then? There is no cold startup, so it is always hot. So you get the response times in milliseconds. You pay 15 euros per month. But the cool story is, all subsequent calls are cheaper. If you're on Azure and you're using Azure functions, the same architecture, and you buy the premium plan, and many companies have to do it because of the networking, then the functions are always hot as well. So the cold startup, the problem you only have, for applications which are, rarely invoked once a day, and then you have to wait 2 seconds once a day. Okay, and yeah, this is what it is. I hope Florin, you cannot ask me what's acceptable. We should ask the users, right? So the question is it okay to spend almost no money for an enterprise server which runs on a Lambda, right? And the user will have to wait 2 seconds once a day, or is better to spend thousands of euros for a Kubernetes cluster? That's the question. This is not a question to me, to business. So someone decides in the project what to do. We as architects or developers, our job is just to show the consequences. So if we install Kubernetes cluster, we have to pay on Azure or AWS 100 euro a month for the control plane at least. And if you have multiple clusters, sums up, and they're not even worker nodes. For 100 euros, you can run a lots of serverless workload actually already. So is adding a single boundary service could be considered versus boundary in each class? What is adding single boundary service could be considered be in each class?
Yes.
I don't understand this, but
yeah, maybe Rahul.
Yeah, Rahul, you have to rephrase. So or just say via voice. So Jon or John Warman asked, this was refreshing to see code that feels more pure than code that feels as it was written only of our levels to play patterns. Yeah, thank you, John. And the cool story is, no kidding, this is why I changed the agenda. This code is 15 years old, what you saw. And the new code is very new and they're identical. And this is what my clients like, because we can migrate, old projects to the new world and skip, the entire framework disaster in between. But thank you, John. I also really like it. And what I really appreciate right now, I'm using, the newest Java 17 features, for instance, like switch expressions and make Java records. This is where I'm more excited than using another framework, I have to admit. So build. So I just use Maven because it's a little bit faster than Gradle. And if you know me already, so I can show you actually, can I show this? I think so, hopefully. So if you go to the POM, you see this is the what we use here is a little bit as free, but we have REST easy, which is JAX-RS. We need this is specific requirement, the web server. Then the REST clients, MicroProfile REST client. We need JSON-B and JSON-B for serialization. I think we can remove that. And we use JSON Web Token and OpenAPI, OpenAPI, MicroProfile Health. And this is basically it. So, and the cool story is, if this were a Glassfish project, we could migrate it to it because Glassfish understands MicroProfile, Quarkus understands MicroProfile, Helidon understands MicroProfile, Micronaut understands large portions of MicroProfile. So this is why I can actually move between the runtimes without thinking about this. And this, as someone mentioned in the chat, for me, startup times are crucial, because if you run in serverless world, the gigabyte second, the calls cost you money, real money. So you will see at the end of the month, if your call is 10% faster, you save 10% money. This is basically it. Okay, now let's see. Next slide. So very important for me, Maven is not a CI/CD. So Maven is very simple. And the CI/CD pipelines happens elsewhere. And the pipeline in my projects is almost, not almost, it's always identical. We build first, unit tests are running. If we have any integration tests are running, then we try it, to deploy as soon as possible the thing to a running environment. Docker container, functions, whatever, bare metal, whatever you have. And then we run immediately the system tests against the domain. So this is what happens, right? And as you already saw, the unit test, all my classes for 15 years already are like Pojo. So there's only a Vue, JAX-RS, or Java EE annotation. So there is almost, the framework is indivisible. Yeah. No dependencies. And by the way, 5 years ago or even 2 years ago, developers told me, yeah, you are the no dependency. We don't believe you. And I always said, I cannot show you the projects because of NDAs. But now the first project already, I was okay to show you this. And the cool story is, with the log4j problematic, it's my clients, start, to question all the unnecessary dependencies. And the cool story is we never had any dependencies in Jakarta EE projects. For instance, I always prefer Java util logging or system logger over log4j. Why? I show you already. If something in Java, I really don't like to pick another thing. So the added value has to be significant to use that, right? So, and then we have all the automation in CI/CD pipeline. It means Maven build is just dump. No plugins. We try to avoid, the entire thing. Okay, runtimes, bare metal, virtualization, containers, or serverless functions. So I would say bare metal can be interesting. Virtualization as well. But virtualization, maybe we'll use for test purposes virtualization. But bare metal, I would say why it's interesting. So what didn't talk about, and I'm really wondering because usually I get the feedback is look, you talk a lot about about Java modularization, but now in the cloud you're changing your mind and you're talking about different architectures. My observation is if you move to the cloud, the only significant factor actually, which is or the biggest influence on the architecture are costs. I call it cost-driven architecture, right? So. And what can happen is that we can start with serverless because this is energy efficient and we get better invoice for the management and everything is more transparent. But our system gets so popular that it's too expensive because if you call a Lambda 100 times per second, an EC2 machine is going to be cheaper. And in this particular case, it is worth to migrate back from serverless to EC2 or I forgot the name on Azure. On EC2 or containers to save money, because you can say, okay, under this heavy load, this use case can be run on bare metal. So now the thing, someone asked me about the startup times. So what I did is, so there is an AWS Quarkus Lambda CDK plain project, and I will use it right now from scratch and show you actually the most modern monolith is it's AWS Lambda. And I would like, and what will happen right now is I will start a script which will clone the thing, and not clone with copy, I have it locally, not from GitHub, and just run it for you, but you can do it at home, no problem. So let's do this. And let's do this here. Set up Quarkus Lambda project and call it CJUG. Should open two IDs. And what I would like to do is I would like to switch to CJUG first. Now I'm here. And then there is a Lambda folder. Now look at this. We go main, Java, boundary, greeting resource. And the code looks like 15 years old, no Glassfish code I showed you. Do you prefer to make clonable GitHub templates over Maven archetypes? In this particular, recently, yes, because it's easier, to copy the code and modify. In some projects, we use archetypes, but if you would like to do a great Maven archetype, you have to spend some time with Groovy. And the problem is, then you have to explain why. And also, there's some friction because with the Maven archetype, you need to have working Maven first. And here I can just clone the code and show it someone. So this is my experience. But I did a lot of archetypes, Maven archetypes, and with Maven archetypes, with the Groovy templates, you can achieve great things. But I would say what's more interesting as a template is building a CLI, command line interface util, which will clone a project, and it could be a mix. You provide, like a small drone or a proxy which clones the project and just provides some Another thing, if you like, I don't use it because there is no significant added value in my project, JBank, if you take a look at this, right? A very good question. Almost forgot this. Florin asked me, 100 calls per second is cheaper than EC2 and serverless. Is it true for the provision concurrency or AWS of premium tier on Asia? So Florin, great question. I actually forgot to mention this. If you buy provision concurrency and there is a lots of calls with the provision concurrency, the more you call the Lambda, the cheaper it gets. So the provision concurrency, if on the heavy load, can be cheaper than Lambda without provision concurrency, but you have to do the math by yourself. But to my knowledge, in all clouds, the serverless stuff is 20-30% more expensive than bare metal, has to be. But the problem is, I think is really hard, or I would even argue in a regular project, impossible to choose the right instance and run it 90% utilization all the time. It's really hard. The cool story in enterprise projects that, the serverless projects, they're running 8 hours a day and at night nothing happens. So in some projects we were running completely for free, with free spike scalability. But the thing is here, this is my Lambda. Florin, I hope you are happy now. And you can see this is our ordinary Java code. So this is like, there is a greeting resource and there's an injected greeter with some, JAX-RS stuff. The greeter gets injected MicroProfile config. And this is basically it. So this is working Lambda. So now the cool story is, because it's Quarkus, so actually go here and say compile Quarkus dev. So, and now what should happen, hopefully, and it happened, usually it doesn't happen because I have some Quarkus which works behind the scenes. It started the development loop, and I can actually go here and say, okay, cool. I can just open this and say curl localhost 8080 hello. And I get the response. So what it means is I can actually run my Quarkus system locally, and it looks for me like my old Glassfish application server. It is as responsive and hot deployments runs right. So if I change it, and let's say local. You see local hello, so it just it just works. Also, it is actually a Lambda, right? So this is the cool part. So now, what if I would like to push it to AWS? So that's the question. So I like Java, therefore my entire infrastructure as code, if I find the editor, is actually Java as well. So this is called CDK. This is a cloud development kit. And I use this actually in all my projects. I would say 2 lines of Java code can easily replace 500 Terraform lines of code. So this is actually the cool story. And I show you what it does. So this is a pretty sophisticated, and this is actually commented out on purpose, because what this does, with this thing, I can deploy the Lambda as function URL, API gateway, or ALB, application load balancer stack. So this is, you might ask why I'm using Java. Simple idea. The cool story is we have the entire provisioning and the source code as a package. So we can package and run it. And by the way, on Azure, we use Bicep. It's like Azure language for it. So not, and on AWS, we use Java. And the cool story is you can build, your higher level, it's called construct. So you like pieces, and you can say new CJUG microservice, right? With 1 gig of RAM and CPU.deploy. And this is your infrastructure. And you can put it to Nexus, to Maven repository. And another developer will just reference, the dependency, and with 1 line of code can provision, already reviewed and validated infrastructure. So this is the idea. So now, what I have here, a script, build and deploy, don't ask, require approval never, because I just run it and this goes fast, like 2 minutes maybe. But I have large, installations where there's lots of networking, can even take 20 minutes. So this is a coffee time. But in this particular case, I would like to execute the build and deploy script and see what happens. And I have, I think, logged into my cloud, and now we have some time, you know, to chat, because now we are shipping actually a full stack MicroProfile application to the cloud, packaged as AWS Lambda, and I will call it, and you will see the cold start performance. And I forgot what is the default setting. Let's see. The default setting is 1 gigs of RAM, and 1 gigs of RAM is half a CPU. We are 0.8 CPU, so it is not, you know, huge implementation. Now, someone asked me about native code, and I answered, I'm not using the native code. Why? Money savings. If you consider the performance of hotspot, so you know, the first call is slowish, and the often we call the Lambda, the faster it gets. GraalVM right now doesn't have this optimization, so it optimizes once and all subsequent calls as fast as the first one. So with GraalVM, you can optimize the startup time, but all the subsequent calls, maybe they are not maybe, they are 10%, 20% slower, which means you will lose with GraalVM 10 to 20% of money. So, and now is the trade-off. How bad is it that one call at a time takes 2 seconds and all others are fast enough, right? So now it ships the Lambda URL. Now it's done. This was the entire infrastructure provisioning with pure Java. And what I got back is the URL. So this is my Quarkus. And what I can do is I will invoke it with curl and time, and hello was it. So, and this is the absolute coldest startup time you can have, is 3 seconds, but it is actually not fair. But this is the entire infrastructure is cold, right? It was the very first call, you know, from here to Frankfurt over the HTTP API gateway. So there was, you know, the entire path was called, not only the Lambda, right? And now watch this. These are the subsequent calls. This is the performance of remote call with Quarkus. So it's roughly 100 milliseconds, right? So, and if I do this without the curl, you will see this is local hello Quarkus Lambda. So what we did, we shipped a monolith Lambda. And by the way, the project you saw, you know, back then is there are 500 classes shipped as a Lambda. And because Quarkus optimizes on the fly, it is as fast as this. So there's actually no problems, right? Now the question is Java, you know, why I'm using Java and not different languages? So that if you go to AWS and you would like to have more CPU, if you would like to have one single CPU, and usually you would like to have, if you have a non-trivial application, then you have to buy 1.7 gigs of RAM. So it means if you buy 1.7 gigs of RAM, you get one CPU. But our application now, it takes maybe 300 megs at most. So we have 1.5 gig RAM left, you know, so there is actually no reason for any optimization. Something I think, you know, could we cache something in memory, because there's a plenty of memory, right? Okay, now the question is why I'm talking here about our serverless. It's showing you this, and the answer is because we are in Europe. I get lots of questions, CO2, energy efficiency, and the truth is, you know, at least the data center in Frankfurt with serverless Lambdas is very green. And this is huge marketing stuff, right? And with Java, we can actually save money, because with JIT and Hotspot, it executes way faster than Python and Node.js. So there's actually, we have a true business case that if you run Java in serverless mode, we can save money. Okay, this was the entire deployment. So you saw that Java ships with or 100 milliseconds round trip time, right? So now what we could do, because we could actually go here and go to calculator at AWS and say, okay, how much would it be for, and by the way, Asia is very similar. This is from cost-wise. So, and let's pick ARM, number of requests 2 per second. and duration, let's say 200 milliseconds. We had 100, let's say twice as much. And I would like to have 1 gig of RAM and show calculations. So I would pay for the entire thing 10 euros a month for my monolith running entire time 2 transactions per second. And and if you do nothing, we get scalability without any service quotas, 1,000 parallel lambdas at the same time. And the cool story is, the Lambda or Azure functions, they sound like fun. But the cool story is, we have 1 CPU and 1.8 gigabyte per call. If there are 1,000 calls, we have 1,000 CPUs. And is it true? Then 1.8 terabyte of RAM. I'm not even 1,000 multiply. Yeah, it seems like, right? Of RAM. And if this were a container, then there's a big container, but this is threaded. Lambdas are processes. Okay. And of course, if I have 200 requests per second, then I will spend 1,500 euros a month. And now is the question, is it now cheaper to provision an EC2 machine or Docker container or whatever? By the way, this talk should be not that much about cloud. What I wanted to show you actually, that the same structure can be used on-premise, on bare metal, in containers, and of course a serverless. So there is no difference, and it works. It is simple and so productive, right? So this is the entire point. But I'm not propagated actually clouds, so I'm a huge believer on-premise because it's way cheaper. But if you go to the clouds, I would say, then you have to really go to the clouds and really pick the features of the cloud and now say, okay, lift and shift, whatever I had on-premise, I do in the cloud, because then you will only pay more without added value. And what's the added value in the cloud? Usually security, certificate rotation, the serverless stuff, full automation. So this is where actually the cloud shines. Okay, questions? Then maybe the first time, because there are no questions, I could try something. If not, or maybe, if you don't believe me, I would just re-authenticate and show you the Lambda. So this is the Lambda. 1 Lambda. This is 14 megs of package. So entire Quarkus with the entire runtime is 15 megabyte, which is large one, right? If you think about this. And this is the Lambda. It was provisioned 6 minutes ago, right? So now, this experiment, and I actually hacked this today, so to make it automatable. You see the snap start, and this is new. I will say true. And what happens now is it will ship this Lambda as crack. What is crack? Crack stands for, I cannot remember this. Coordinated resource at checkpoint. Coordinated resource sharing at checkpoint, or coordinated resource at checkpoint, I think. Coordinated restore at checkpoint. Logan, you are golden. Thank you. Coordinated restore at checkpoint. I cannot remember this. This is OpenJDK technology. And this is now heavy because it will migrate the Lambda from ARM to x86 because it is not, or migrate, it will tear down the old one and provision a new one. And if it doesn't work, I will tear it down because, and deploy it once again. So let's do this. Gerrit is at Azul. Gerrit Grunwald is from Azul. Crazy. Gerrit is is a really nice guy. So okay, cool. Gerrit is. I didn't know that he's on Azul. Cool. Thank you, Logan. So now this will take longer, but because if it works, it will. This will actually deploy the Lambda, start it, perform optimizations, then freeze it. And then we can call it again. Yeah, but a second, I will have to destroy the environment and do it again, and then I will ask questions. I think we are over time anyway, right? I forgot the time again. Mary, is it true? I think so, right?
Sorry, I mute. No problem. Yeah, you can keep going. We are having this recorded, so yeah, no worries at all.
Exactly. So, and what you talk about, I would just wait until I cannot do this. I will have to tear down the stack and do it again because I'm migrating now from, you see, ARM64. I have to go to Intel back, and I never tried this actually. So let's see. So I would say GraalVM is not a must. With GraalVM, you can optimize code startup, but Crack as well. And my bet is on Crack right now with JIT and Quarkus. You can use Micronaut. No experience with Spring Boot. I don't know how fast, what the startup time of Spring Boot is. So I cannot tell you this, but you saw the Quarkus, and I say in all my projects like that. We use actually this exactly the same MicroProfile Jakarta EE stack what we used 15 years ago and now on serverless Lambda. Our Lambdas are fat, monolithic Lambda. No one cares. The deployment is simple, and we don't have, to ship 500 Lambdas. But if we do so, we have one Maven projects and multiple Lambdas in our projects, and the Lambdas are boundary. So there's no difference. So what Quarkus provides is deployed build time. What's really interesting in Jakarta EE is CDI Lite. So what is deployed build time? What Quarkus does, it looks at the bytecode. It says, okay, I read, all the XML, all the configuration, and generates optimized bytecode. At build time, so at runtime, there are no class loaders, no fancy configuration, just, dump optimized bytecode. So, and Micronaut does the same, but Quarkus does it with extensions, and Micronaut does this with, how it's called, compiler, not compiler extensions, with the compiler API. I forgot what it is. It just, reads annotations and generates compiler code. And the CDI Lite is actually part of the Jakarta EE core, and the CDI Lite tries, to provide dependency injection without reflection. Okay. Also interesting technology. Take a look on this, Payara Cloud. What it does, they're using Payara as a Kubernetes operator. Very interesting idea. It's also serverless. Okay. And Logan, which is highly skilled here, he should be the speaker, not me, right? So the only contribution I had today was about the great movie. So everyone was excited. But what Logan says is Project Layden in OpenJDK will also try to improve the startup time to peak performance and footprint of Java programs. Yes, they try, everyone tries that. But as you already saw, this is already impressive and very usable. Let's see what happens here. Okay, so what I will do is I will try to destroy the stack and then run it again. Okay. So in tests, we already said it. Forgot to mention this. In my projects, I always start with system tests. Unit tests don't matter first. We always start with, the black box tests. And after the project becomes more and more complex, we then introduce system tests. So that's the deal. Okay, and this is, in the tests, we have a resource, and what we do there is an interface, which is a MicroProfile REST client. You see the register REST client. It means what the MicroProfile runtime will implement on the fly implementation for it. And then in the test, I can just inject the interface, and I have my black box test. That's basically all. Okay, and these are the resources. So this is, the X-Ray 15 years old, Lightfish 15 years old, and these are the templates. So I can say, send the slides to Mary. So Mary could share the slides. And there is 10 years after, this was the interesting talk where I migrated, old Java applications to AWS Lambda. And also funny, this was actually fun. I forgot about that. There's a talk on YouTube, EJB developers, now is the time to go serverless. So if you had more time, I would actually prove the point that the EJB concepts are one-to-one to Lambda. So actually, if you know EJBs, if you look at the Lambda, they're exactly the same concept. So, all EJB developers are now Lambda gurus, which is also interesting. It could be actually idea for another talk next year. If you like, maybe I will see another movie and suggest you to about Chicago. Okay. Now, this is the problem. You see, don't ask. So, any questions? Mary, ask questions. If no, here's
busy.
one.
Well, no.
For your info, in case you cannot stay longer until Adam. This is not for me. It's just for all of you.
Yeah,
okay.
Just so I know, because it goes over, but no worries. I feel you need to take your time and finish. So, question. Yeah. So, okay. Now I got to think of question. I'm too busy organizing things. Yeah, it is great. Yeah.
To the others, you can ask me now also via voice if you like, so you don't have to write the stuff, right? So are actually the Chicagoan? How's it called? Chicagoan? How is Chicago citizens? Are Chicago citizens so shy? They never ask questions, right? I think the New Yorker are better, right? The New Yorker always, yeah, they are.
Oh, really?
Yes,
I don't
some
know.
of us concerned be shy. But no, I
Be
thought it was a
shy.
great presentation. I definitely need to play around with Quarkus some more. But yeah, excellent stuff.
Yes, exactly. So
Thank you. And what I showed you right now, we are actually used this in production for years. So there's nothing new. I just wanted to share with you. And the most common questions about the structure actually, right? So how, structure applications. And for me, it was always obvious. So, but after 15 years, this was one of the view sessions. I talk about this and everyone said, okay, yeah, it's actually right. Why not, to think about business? And we don't have to know, I don't know, DAOs, services or whatever, because who cares about a service package, I would like to what's inside, not what it is, right?
that's true.
Any other questions? We have to wait. We have 2 minutes. I think this will take a little bit longer, but then I'll show you and crack optimize or snap. So the crack coordinated, restore at checkpoint. Exactly. So this crack is called snap start on AWS. So AWS also contributed to OpenJDK and they built into Lambda runtime. And what happens behind the scenes, they optimize, the JVM and they share the optimizations within the region. So if you start another Lambda, it already is cracked, right? So this is, so whatever I can, I use this in production. In some Lambda systems, we are using Java 17, but this is only available for now for Java 11. But I'm pretty sure, this year we'll get full support.
Yeah, I do find it interesting that they don't really have support out of the box for Java 17 yet, especially given that the next LTS, which I think is 21, is right around the corner. There's been some interesting discussion on the GitHub issue and Lambda for 17 support. So hopefully they push.
Yeah,
it
but
soon.
because they would like, they would like to lift the entire platform and do some, not only the runtime but also the API stuff, what to do behind the scenes. So this is the idea. Yeah. Behind the scenes, but one thing, if you really would like to have Java 17, not a problem. You can ship a Java 17 layer. That's what we are doing, and then we have full Java 17 support, but without crack. But the performance, startup time, and whatever is very similar. So I'm actually using in all my projects Java 17, and I could use Java 20 as well, no problem. And now the optimization happens. So now you see the snap. What happens behind the scenes, but it's only slow the first time. It just creates a new version, an alias of the Lambda, and it is now cracked. So if we go to the console, actually, we should see that it starts and it's going to be frozen. So let's see. So this is 2 minutes ago. And if we go here and monitor, I think, CloudWatch logs. Log groups and greetings, too many greetings. Yeah, this is today. You see, it started this Quarkus in 3 seconds. This was init report for the crack optimization. So, and now it started. So this took, 200 seconds. It was 3 times longer with the crack optimization. So, and let's see, I go here. Curl with some time measurement. It's just an alias. If we do this was too early. Or is it something? No, it's not called. Now it's called. 1.4 second. But this is slow. Usually it is, now it's, but it is like now the startup time. But this is not a really cold again, because now the entire infrastructure was created. Now we have to wait until it becomes cold and call it once again. So usually is 1 second, under 1 second. So you saw now the cold start with crack, right? You see. Okay, cool. So you saw now why I'm using Quarkus, how I'm using Quarkus. And the cool story, I use the Quarkus right now, but if Quarkus should die, I'm pretty sure OpenLiberty will take over, or Helidon, or Omnifish, this is the Payara guys, or the Glassfish guys in the chat, and migrate to code to another runtime. So this is actually the beauty of MicroProfile and Jakarta EE, that for years we always find a better environment. We can delete more and more code, and there are no migrations without reason. And Logan says Helidon. So Helidon is going to be extremely interesting. So if you go to Helidon, what Helidon is working on NEMA, and what NEMA is, they very soon they will provide MicroProfile support for or MicroProfile will run on Loom. It means you can have millions of transactions in parallel with no implications on memory. So really interesting project. Now the question to Logan: why are you so not knowledgeable? Logan is on fire. So are you like
It's a good question. I think I'm relatively new to the field. I graduated in 2021, but I try to keep up with what's going on, in the greater Java community. I tried to read the mailing list, listen to a ton of podcasts, yours included. So I just find it very interesting.
Yeah, Logan, and you graduated in 2021. It's interesting that you like Java and not, I don't know, Node or whatever.
Exactly. Yeah, I actually fell in love with it in AP Computer Science when I came across a video from Brian Getz talking about how they implemented Lambdas. But yeah, it does seem like, people are in love with other languages, but I just have fallen in love with Java and kept up with its progression.
What I appreciate in Java the most is it's really hard to write code which no one understands, right?
Yes, exactly.
Because Java is chatty, but it is understandable. So yep. I have to tell you, I tried Scala once, and you can write a beautiful Scala code, but if you look at the libraries, I couldn't understand what's going on. So I clicked once and I said, okay, what's going on? The cool story in Java is if you click at the Java source code, you can actually fully understand it if you like, right? So this is what I really appreciated for years. So and there's no magic like in Ruby at the meta programming, and you can swap. It was nice, but I mean, I couldn't imagine a larger project to do such magic, right? So I was okay. This is really crazy.
Yeah, a lot of interesting stuff.
Yeah, cool, Logan. Perfect. So
That's right.
So I would say I think we are done, right? So we have here the resource slides. Yeah, if you like, you can attend workshops, but they are very similar to this one, just hacking all the time. And I thank you for. And the first time I was in Chicago, so it's a nice place.
Yeah, virtually.
Virtually, yeah.
Yeah.
And
great.
Thank you a lot, and see you next time.
Thank you. Thank you so much, Adam. And and I think just to make sure nobody has any more questions, or if they have questions, they can always
just ask. This is really Logan should get a t-shirt and everything, but everyone else, I don't know what's wrong.
That is so true. Yes. Thank you.
Yeah, and then we still do have the raffle for those that are here. We have a wheel of names for the IntelliJ raffle. So once you're done, we'll draw those names.
That's right. Yes. So Logan, if you want to bring up that wheel, right? Yeah.
I get a question. What is the URL for the GitHub?
Yeah.
You will see this on the slides, but if you go to GitHub, my name, Adam Bean, and I think this is what you see, and this is the first template, Quarkus Lambda CDK plain. This is what I use right now. And the other one is Lambda without Quarkus. And this BCE design is interesting for you, maybe. This BCE design is used by lots of companies. This boundary control entity applied for web components in JavaScript. So without Java, but this is the same structure. So we use it also. And
Great, thank you. Yeah.
Mm-hmm.
And what else? I think I see Max. Did you raise your hands or something on the chat there?
Yeah.
I see the chat. There's the Max said just thanks. So thank you all. Yeah.
Okay.
Yeah, actually, I'd like to do a question for Adam, because I have been following you through those years, and I see that you are using plain tests with the unit in your case classes and so on. But you are mentioning about MicroProfile. I think that Quarkus has a good background to test those things. I think the developer experience is so good in Quarkus and another MicroProfile stance. But for Jakarta EE, do you think that Archelion is a good one yet, or it's better to focus on simple JUnit test and something like that?
So first, very good question first. So for me, the question can be widened. So the question is, if you go to the cloud, how you test the thing? You know, is there, you have a kind of a local stack, or you go to the cloud? And for me, I tried always to avoid Archelion. And instead of Archelion, I booted the Glassfish, the Payara, the Whitefly, and ran true tests against the true thing. So I don't trust the emulation a lot. You know, this you can cause you a lot of trouble. So what means, I forgot to mention this, why I really like serverless, one of the main reasons where serverless excels in all clouds is pay as you go. So what it means is, if you don't call the stuff, it costs you nothing or very little. What means is, we have in the history of Java the unique opportunity to have developer environments for free, which are identical to production. So in my projects, every developer gets either the opportunity or own AWS account or Azure account. Right now I'm in AWS project, but this is why I'm remembering the AWS names better. But soon I will do Azure as well in a project. But we get Azure or AWS account or Azure subscriptions, and then we can ship, actually, I could ship this Lambda, exactly the same Lambda, to production into my dev environments, and they will behave the same with different URLs. You cannot do this with Kubernetes, for instance, because you will have, you know, if they have a huge Kubernetes cluster with different projects and care about isolation, or every developer gets, you know, an own Kubernetes cluster, but you will have to pay 100 euros per developer per stage per month for the control plane alone without the worker nodes. So this is why I say the serverless is really the future. And, you know, if I mention, this is actually a funny thing, it is, at least in Europe, that we are CO2 efficient or energy efficient, everyone listens. Wow, what are you doing? And we are just, I'm just running my old application servers Lambda, right? So this is nothing special, but everyone gets excited. So what means, whoever asked the question is, in Archelion was the same, in clouds is the same. I always try to use as soon as possible the real thing. The real Whitefly, the real JBoss, WebLogic, whatever we had, always use the real thing, startup. And, you know, back then, we had to buy beefy machines to start fast. This is why I didn't like never WebSphere and was a huge fan of OpenLiberty, of the WebSphere small. And, you know, Whitefly was better. Quarkus is even faster. So startup times were always important for me because of developer experience. The faster it starts, the faster you can test, right? So the developer turnaround cycles. So, and in Lambda is the same, but here what I showed you is I don't do this in production. What happens in production is we push to GitHub or Git commit, usually GitHub. Then there is an AWS app which goes to the code pipeline. It checks out the code, builds the Lambda. I don't have to wait for it. And I if I like, I can get notification whether the build was successful or not, for instance. So I don't use Archelion. And for system tests, maybe it's already open. This is the last thing. If we go to Ujumbe, which is what we're building is a nice chat, actually. So these are the system tests. And if you go here and I show you, for instance, what I built recently, rooms. So this is the client, MicroProfile client. And there is wait a second, we are in source main Java. This is the client, and in source test Java, it is in source test Java. Rooms are the system tests. And we have, for instance, so this is how it looks like. We inject, you know, the REST client, and then we write the tests. So this is complete black box tests. And what I also did is the sync, for instance, and in the So incremental sync, this is how it looks like. So we fetch, the tokens, and we write the logit. It means assert that incremental join events, there were no changes after subsequent joins. Okay, to make the output nicer, and this is actually the code, just JUnit code. And this is we also don't use test containers, because I don't like to start the entire environment on my machine. I would like to start the real thing. So this is why I also would like to have a serverless storage. This is the reason why I use S3. If S3 wouldn't work, I would use DynamoDB or Cosmos DB. If this doesn't work, I would use relational database. I try to avoid relational database in the cloud. Reason being is, if I have to run a relational database in the cloud, is a lot to do. Backup, multi-region deployment. This is a lot of stuff we have to care about. In serverless environment, there is nothing to care about. You just say, give me a table, and you have the table. Okay, long answer to short question, but I hope it is answered.
No, thanks a lot. Thanks a lot.
Okay, great. Thank you. All right. Well, thanks for asking all those questions. And I know it is getting a bit late now. It's like 2 p.m. in Central Time, and then which is like 9 o'clock here in
exactly
European time, right? Yeah. Okay. Thank you so much again. Thank you.
Yep.
To Adam, to Logan helping, and Jay helping with everything, Max being here, everybody else too. Who's here. So thank you very much. And I will just leave this on for a little bit if you want to hang out, but otherwise too, the meeting is adjourned. But again, feel free to hang out for a little bit. So.
Free beer right now.
Beer, yeah, that's right.
Beer and pizza.
Virtual
beer. Let's see that they have these emoji, right? Beer. Beer.
Yeah, this is a very healthy way of
That's right. Yeah, this is healthy. Yes, that's right. Dry. Yeah, but feel free to bring your drinks here, virtual drinks. So yeah, thank you again.